Here we learn about an important concept in chemistry known as stoichiometry. This video is not made for beginners. Stoichiometry is a measure of quantities relationship between reactants and products. Let's take an example to understand this. Suppose when something is being produced in an industrial scale, they want a specific composition of the ingredients and a specific number of products. If they want to make 5,000 soaps, they want to make 5,000 soaps. To do that, they need to know how much of what is there. They need to go how many molecules of this, how many molecules of that is there to get the desired quantity. The first thing we are going to learn in stoichiometry is the concept of moles. Suppose you want to buy 36 apples. You go to a store and you find someone else who's buying 3 dozens of apples. 36 apples, 3 dozens. Both of them are the same, but 3 dozens is much better and much easier to use. Let's take another example. Suppose you want 5,31,165 milligrams of sugar. Is it easier to say this or just saying 532 grams or 531 grams of sugar? It's definitely easier to say 531 grams of sugar instead of saying 5,32,165 milligrams of sugar. We all know that atoms are incredibly small. Because they're really small, we never take 1 or 2 or even 1,000 atoms in a reaction. It's still a really small quantity. To get an idea of how small atoms are, we'll find out how much molecules of water are present in 1 gram. 1 gram of water contains and many more zeros of molecules of water. I think we've got an idea now. Atoms are really small, so we can't keep writing such huge numbers every time. Which is why we have moles. Mole is like you're saying 1 mole is these many particles, so that you don't have to write this huge number. To get the exact figure, 1 mole contains 6.022 into 10 to the power of 23 molecules. That's 1 mole. You might ask, why is this value 1 mole? Why can't it be something else? Originally, a mole was defined as the number of particles present in 12 grams of carbon-12. Carbon-12 is an isotope of carbon with 12 neutrons. So the amount of molecules that was present in 12 grams of carbon-12 was this number. So 1 mole became this number. The measure of a quantity in stoichiometry can be mass of solids, that's measured in grams, volume of liquid, centimeter cube, volume of gas, decimeter cube, and the number of representative particles. That's basically this. Number of moles is calculated differently based on if you're taking solid, liquid, gas, or whatever values you have. In this video, we look at how to find the number of moles in a substance based on its mass when it's in the solid form. The formula for that would be number of moles, it is represented by MOL, mole, equals mass, that's in grams, by molar mass, that's grams per mole. Let's learn how to use this formula through an example. The question here is, calculate the number of moles in 6 grams of carbon. Number of mole in 6 grams of carbon. This is what we have to find out. The number of moles in 6 grams of carbon. To find that, we need to go to the periodic table. In a periodic table, every element has two numbers, the atomic number and the mass number. The atomic number is a number at the top and the mass number is a number at the bottom. Over here, we want to look at the mass number. When it says molar mass, you can consider molar mass or atomic mass based on whatever, if you have a molecule or if you just have an atom. So over here they're asking for carbon. So we need to check what's the atomic mass of carbon. That's 12. We can round it off to the nearest integer. So we'll say MOL equals 6 divided by 12. That's 0.5 mole. That would be our answer. Now let's take another question. Calculate the number of moles in 100 grams of NaCl. So over here we want moles in 100 grams of NaCl. Over here we're looking at a compound. We're not looking at a single element anymore. Our formula: mole equals mass by molar mass. What have we been given in the formula? We have been given the mass, which is 100. We need to find the molar mass. I'll tell you how to find the molar mass of a compound. All we have to do is take the individual elements the compound is made of, find their average atomic mass, and add them up. So for sodium, it is 23. On the other element, chlorine, it is 35. So 23 plus 35, that's 58. 23 plus 35, that is 58 grams per mole. So 100 divided by 58, that would give you 1.72 mole. That's your value. Let's take a look at a different question where we've been given probably molar mass and mole, and they want us to find mass, or they given us molar mass and mole, or mass and moles, and they want us to find molar mass. All we have to do in such cases is change the subject of the formula. Let's look at an example for that. What will be the mass of 3 moles of Fe2O3? Mass of 3 moles of Fe2O3. That's what we have to find. Over here we have the number of moles and the chemical formula of iron oxide. First, we need to find the molar mass of iron oxide. To do that, we need to first find out the atomic mass of iron and oxygen. The atomic mass of iron is 56 and that of oxygen is 16. So, we'll write 56 and 16. 56 and 16, but this is not complete yet. We have 2 iron and 3 oxygen atoms. So we have to multiply this by 3 and multiply this by 2. And that would be 112 plus 48, which would result in 160 grams per mole. We have a value. Now, what we have to do is take the formula and make mass the subject. So that's basically move molar mass to the other side. Mole into molar mass will give you mass. Because it's being divided over here, if you move the term to the other side, it will be multiplied. So you have your moles, that's 1.7. Okay, never mind, that's 3 over here, this is the question. So 3 into 160. This is one question. 3 into 160. That is going to give us 480 grams. 480, we need 480 grams of iron oxide to get 3 moles of it. Now let's find out how to find the molar mass in some tricky compounds, basically which includes polyatomic ions. What will be the molar mass of aluminum sulfate, which the chemical formula of that would be Al2SO4 thrice. First, let's start with what we already know, and that is how to find the molar mass of aluminium, Al2. To find the atomic mass of aluminium, we need to go to the periodic table. Here we go, we have 27. There is 2 of it, so 27 into 2, that would result in 54. So 54, we know we have to add it to the other values. Now, first we have to do what is in the brackets. 4 oxygen and 1 sulfur. Sulfur 32, oxygen 16. So 32. And then we have 16 into 4. That will give us 64. So 32 plus 64. And that is 96. Now, outside the brackets of SO4, we have a subscript 3, which means we need to take 3 moles of SO4. So we'll just say, we'll do 96 into 3, which is 288. Now, we can add this value to 54 to get the molar mass of aluminum sulfate. So 54 plus 288 is 342. 342 grams per mole. This is all for this video. Thank you so much for watching. Subscribe to our channel, like the video, and comment down your thoughts about the video.